I'm going to tell you something that will fundamentally break how you understand reality. Right now, at this exact moment, there is an invisible wall surrounding you. Not a wall you can touch, not a wall you can see, but a wall so absolute, so unbreakable, that no force in the entire universe can push you through it. Moljam, this wall says you cannot go faster than 186,282 miles per second. And here's what's going to collapse your mind. This isn't because we haven't built the right spaceship yet. This isn't because we need better fuel or stronger engines. It's because going faster than this speed is like trying to find a married bachelor. Like trying to make a triangle with two sides. Like trying to be in two places at the same exact moment. It's not difficult. It's not expensive. It's impossible. Logically, fundamentally, completely impossible. The universe has built this wall into the very fabric of reality itself. And when you understand why, really deeply understand why, everything you think you know about space, time, motion, and existence will never be the same. And let's find out what's really going on. Let me start with something simple. Something so simple you might think I'm wasting your time. But stay with me. You're driving a car. You're going 50 miles per hour. You push the gas pedal. What happens? You go faster. 60 miles per hour. Push it more, 70 then 80. Now question, why should there be any limit at all? I don't mean the limit of your car's engine. I mean a universal limit. A cosmic speed limit that applies to everything, everywhere, always. Lambda on Earth, if my car maxes out at 100 miles per hour, that's my car's problem. It's an engineering limit, but there's no universal law that says nothing anywhere can go faster than 100 miles per hour. That would be ridiculous. So why is there a universal law that says nothing anywhere can go faster than 186,282 miles per second? What's special about that number? Why not twice that? Why not 10 times that? Why not infinite? Why have any cosmic speed limit at all? Aiko. Think about it. Really think about it. The universe is enormous. Space is vast. Why should space itself care how fast you move through it? You know? And here's another thing that should bother you. That number, 186,282 miles per second, that's the speed of light. But why should light be special? Light is just electromagnetic radiation, just photons. Why should the speed of one particular thing in the universe be the speed limit for everything? Something strange is going on here. Something really strange. And the answer is going to take us deeper into the nature of reality than you might expect. All right, let's do an experiment. A thought experiment, but it's based on real experiments that physicists do every single day in laboratories around the world. Semdia, I've got an electron here, tiny little particle, one of the basic building blocks of matter, just sitting there, minding its own business. Now I want to make it go fast. So I'm going to push it, I'm going to add energy to it, and Newton told us what happens. Minus force equals mass times acceleration. You push something, it speeds up. Simple. So I push my electron, it speeds up. Great. Let's say it's now going at 10% the speed of light. That's fast, really fast. About 18,000 miles per second. Let me push it more. Add more energy. Now it's at 20% light speed. Then 30%. Then 50%. I keep adding energy, it keeps going faster. Everything's working exactly like we'd expect. But now minus. And this is where the universe starts playing a very peculiar game with us. Something else begins to happen. Something that wasn't in Newton's equations. Something nobody expected until it was actually discovered and measured. It starts getting heavier. Not heavier because it's picking up other particles. Not heavier because dirt is sticking to it. Heavier because its mass, its actual fundamental mass, is increasing. Now, you might think I'm making this up. I'm not. This is measured. This happens. We see it in particle accelerators all the time. A moving electron literally has more mass than a stationary electron. Let me be really clear about this because it's so strange. Mass is not constant. Mass depends on velocity. The faster something goes, the more massive it becomes. Okay? So the electron is getting heavier as it speeds up. Let's keep going. Let's push it to 70% of light speed. The mass has increased significantly now. At 80%, even more at 9. The electron is more than twice as massive as it was when it was sitting still. Blams. But watch what happens as we get closer to light speed. At 95%, the mass is about 3 times the rest mass. At 99%, it's 7 times heavier. At 99.9%, over 22 times heavier. Vaughn, do you see the pattern? It's not linear. As you get closer and closer to light speed, the mass doesn't just increase, it explodes upward. The curve gets steeper and steeper. Amanda, at 99.99% of light speed, the electron is over 70 times more massive than it was at rest. Demdy at 99.999%, over 700 times more massive. The closer you get to light speed, the faster the mass grows. And here's the kicker. At exactly light speed, at precisely 6,282 miles per second, the mass becomes not very large, not bigger than a galaxy. Infinite, actually infinite. Now think about what that means for acceleration. To accelerate something, you need force. The more massive something is, the more force you need. That's basic physics. Bonjand. But if the mass is growing as you accelerate, you need more and more force just to keep accelerating at the same rate. It's like pushing a snowball uphill that gets bigger every time you push it. And to accelerate something with infinite mass, you'd need infinite force, infinite energy. How much energy is infinite energy? It's not all the energy in the universe. It's not all the energy that could ever exist. It's infinite, meaningless, impossible. The universe has created a trap, a perfect trap. You can get arbitrarily close to light speed, 99.9999% of the way there. But the last little bit, that final step to actual light speed, impossible. Completely, fundamentally impossible. Now, if you're paying attention, and I really hope you are because this is important, you should be thinking, wait just a second, light travels at light speed. That's why we call it light speed. So obviously it's possible. Perfect. That's exactly right. That's exactly what you should be thinking. So how does light do it? How does light avoid this infinite mass problem? Well, here's the answer, and it's beautiful. Light has no mass. Zero mass. Not a tiny bit of mass. Not almost no mass. Zero. Completely, perfectly massless. Linda photon, a particle of lightness, weighs nothing. It has zero rest mass. And if you have zero mass, then you don't have the mass increase problem. 0 times anything is 0. There's no mass to increase. Lands. But here's what's truly remarkable, and this is where it gets really interesting. If you're massless, you don't just get to travel at light speed. You must travel at light speed. You cannot travel at any other speed. When a photon doesn't have a speedometer where it can choose to go slower if it wants to. from the instant a photon is created to the instant it's absorbed, it moves at exactly one speed, 6,280, 2 miles per second. Not faster, not slower, exactly that speed. Think about what the universe is telling us here. It's drawn a line, perfect absolute line. On one side of the line, everything with mass. These things can go at any speed less than light speed. They can be stationary, they can go fast, but they can never ever reach light speed. They're locked out. Land. On the other side of the line, everything without mass, these things must go at light speed. They cannot go slower. They cannot go faster. They're locked in. There is no middle ground. You either have mass and can never reach light speed, or you have no mass and must always travel at light speed. The universe has sorted everything into two categories, and the boundary between them is absolute. Now you might wonder, why does having zero mass mean you must go at light speed? Why can't massless things go slower? That's actually a deeper question that involves the structure of space-time itself, and we'll get to that. But for now, just appreciate the elegance. The universe has a speed limit, and only massless particles can reach it, because only massless particles don't get heavier as they speed up. Okay? So we've got a speed limit. We understand why things with mass can't reach it. We understand why things without mass must travel at it. But there's more, so much more, because the speed limit isn't really about speed at all. Let's talk about time. Plumdens, you think time is universal, right? 1 second for me is 1 second for you. Time flows. Same rate for everybody. A clock is a clock. Wrong. Time is not universal. Time is not the same for everyone. Time runs at different rates, depending on how fast you're moving. This sounds like science fiction. It's not. It's measured fact. In 1971, scientists did an experiment. They took atomic clocks so precise they can measure time to billionths of a second. They synchronized them perfectly. Then they put one clock on an airplane, flew it around the world, and compared it to the clock that stayed on the ground. Blam, the clock that flew on the airplane was behind. Not by much, minus just a few hundred nanoseconds, but it was measurably definitely behind. The moving clock had ticked slower than the stationary clock. This isn't some quirk of the particular clock they used. This is time itself running at different rates. We see this effect everywhere now. GPS satellites in orbit have to constantly correct their clocks because they're moving relative to us on Earth, and their time runs at a different rate than ours. If we didn't account for this, your GPS would be off by miles within a single day. So time runs slower when you're moving. But how much slower? Well, it depends on how fast you're moving. Lands at everyday speeds, driving in a car, flying in a plane. The effect is tiny, billionths of a second over hours. You'd never notice it without an atomic clock. But as you approach light speed, things get dramatic. Manned at 50% of light speed, your clock ticks noticeably slower than a stationary clock. At 86% of light speed, your clock runs at half speed. For every 2 seconds that pass for someone at rest, only 1 second passes. Bend at 99% of light speed, time is running at 1/7 normal speed for you. At 99.9%, 1/22nd. The closer you get to light speed, the slower your time goes, and at light speed itself, time stops. Completely stops, not runs really slowly, stops. Lenjet for a photons. If we could somehow experience what a photon experiences, which is a strange thing to say because Experiencing something requires time to pass, no time passes. Zero time, think about that. A photon leaves the surface of the sun. From our perspective, it takes 8 minutes to reach Earth, 8 minutes of travel time. But from the photon's perspective, there is no travel time. The moment of leaving the sun and the moment of hitting your eye are the same moment. No time between them. Light speed isn't just a velocity, it's a boundary. A boundary between experiencing time and not experiencing time. Between existence as we understand it, where things happen in sequence, where cause leads to effect, where there's a before and after minus, and something completely different. Now here's where your mind should stop to break. Why does this happen? Why does time slow down when you move? The answer is profound, because space and time are not separate things. They're woven together. They're different aspects of the same thing, space-time. Lands. When you move through space, you're also changing how you move through time. The faster you go through space, the slower you go through time. They're connected, inseparably connected. No. And the total speed you move through space-time, combining your motion through space and your motion through time minus is always the same, always constant, always exactly light speed. You're moving through space-time at light speed right now. Yes, you right now. You're just moving almost entirely through the time dimension rather than the space dimensions. That's why you experience time passing normally. Lend. When you get in a car and drive, you're shifting a tiny bit of your motion from the time dimension to the space dimensions. So your time runs a tiny bit slower. The faster you move through space, the more you shift. And if you could move through space at light speed, which you can't, if you have mass minus, you'd shift all your motion from time to space. Time would stop for you. This is why light speed is special. It's not just the fastest you can go through space. It's the rate at which space-time itself operates. Crowder. Now I'm going to tell you the deepest reason why the light speed limit exists. And this is the part that should truly collapse your mind. Now, just imagine that we could somehow go faster than light. I know I've told you it's impossible, but let's pretend. Let's say we found some loophole, some trick, some way to cheat the universe. You're on Earth. You send a signal to Alpha Centauri 4 light years away, but you send it faster than light. Let's say it gets there instantly. From your perspective, you sent it at noon on Monday. It arrived at noon on Monday. Simultaneous events. Makes sense, right? But here's the problem. Here's where reality starts to crack and crumble. Man, your friend, is on a spaceship moving at, say, 50% of light speed relative to Earth. They're observing these same two events, you sending the signal and Alpha Centauri receiving it. But because they're moving relative to you, because time and space are relative, they disagree with you about when things happen. Not by a little, by a lot. When they calculate the timing using the perfectly correct equations of relativity, they see something impossible. They see Alpha Centauri receive your signal before you sent it. Then the effect happens before the cause, not almost simultaneously. We can't quite tell which came first. They definitively, measurably see the effect before the cause. Now, you might think, okay, that's weird, but so what? It's just a matter of perspective. No. This is not just perspective. This destroys logic itself. If effects can happen before causes, then causality breaks down. And if causality breaks down, reality becomes self-contradictory. Piand. Here's a simple example. Suppose I build a machine that receives signals from the future. When it receives a signal, it's programmed to not send that signal. So if it receives a signal, it doesn't send it. But if it doesn't send it, then it never receives it. But if it never receives it, then it does send it. But if it sends it, you see the problem? We've created a logical paradox. The signal both exists and doesn't exist. Cause and effect form a circle that contradicts itself. This is called the grandfather paradox in time travel discussions. If you go back in time and prevent your grandfather from meeting your grandmother, then you're never born. But if you're never born, you never go back in time. But if you never go back in time, your grandfather does meet your grandmother, so you are born. But then you do go back in time, round and round, logic eating its own tail. And the universe doesn't allow this. It can't allow this. Because if cause and effect can be violated, then logic itself fails. Mathematics fails. Science fails. Prediction becomes impossible. Knowledge becomes impossible. Reality would be chaos, pure, meaningless chaos. The light speed limit prevents this. By making it impossible to send signals faster than light, the universe ensures that every observer, no matter how they're moving, agrees on the order of cause and effect. Cause always precedes effect for everyone, everywhere. Always, the speed limit isn't there to prevent you from traveling fast. It's there to keep reality coherent, to keep the universe from collapsing into logical impossibility. But now we get to the deepest truth, the thing that ties everything together, the thing that explains what's really going on. We call it the speed of light. But that's misleading. That's a historical accident because light was how we first measured this speed. But it's not about light. What we're really talking about is the speed of causality, the speed of cause and effect, the maximum rate at which anything can influence anything else. Light travels at this speed because light is massless. But the speed itself is more fundamental than light. Gravity also propagates at this speed. If the sun vanished right now, poof, just disappeared, Earth wouldn't immediately fly off into space. We'd keep orbiting for 8 minutes. Why? Because the change in the gravitational field propagates outward at the speed of light, not because gravity is light. Because both gravity and light are massless influences that propagate at the maximum speed the universe allows. Any massless particle travels at this speed. All of them, always. None the speed isn't a property of light or gravity or any particular thing. The speed is a property of space-time itself. Here's the real picture. Space-time is a 4-dimensional fabric. 3 dimensions of space, 1 dimension of time, all woven together. And the speed of light is the conversion factor between the space part and the time part. I mean, it's like asking, why are there 5,280 feet in a mile? Well, that's just the definition. That's the conversion factor. That's what a mile is. Lean. The speed of light is the conversion factor built into the structure of space-time. It tells you how space and time relate to each other. It's not a speed limit that was imposed. It's part of what space-time is. When physicists write down the equations of space-time, Einstein's equations of general relativity, the speed of light appears as a fundamental constant. It's woven into the mathematics. You can't change it without changing what space-time is. Imagine a very real sense. The speed of light is the speed of reality. It's the rate at which information can propagate. It's the maximum speed of cause and effect. It's the boundary between time-like and space-like intervals in space-time. bonds, everything in the universe operates at or below this speed, because this speed defines how the universe works. Let me tell you something wonderful. The universe could have been different. Maybe. We don't really know if it could have been, but let's imagine. Imagine a universe with no speed limit, where you could go arbitrarily fast, where light traveled at infinite speed, where gravity acted instantaneously. You might think that would be better, more convenient. No more waiting for light to travel from distant stars, no more delay in gravitational effects. But that universe would be chaos. Without a speed limit, causality becomes ambiguous. Different observers would disagree wildly about when things happen. There would be no consistent notion of now across space. The concept of simultaneous events would be meaningless. Worse, time and space would be completely decoupled. They'd be separate, unrelated things. There would be no elegant four-dimensional space-time, no relativity. No deep connection between how things move and how they experience time. The physics would be uglier, much uglier. Instead, we live in a universe with an elegant structure, a universe where space and time are unified, where there's a cosmic speed limit that ensures causality works consistently, where the laws of physics are the same for all observers, no matter how they're moving. The speed of light, the speed of causality, is what makes this elegance possible. And here's what's truly remarkable. We figured this out. Humans, curious humans with limited lifespans and finite brain power. We measured the speed of light. We noticed that moving clocks run slow. We accelerated particles and watched their mass increase. We thought about what it all meant, and gradually, piece by piece, over decades of work, we uncovered one of the universe's deepest secrets. We discovered that space and time are one thing, that the universe has a speed limit built into its structure, that this limit isn't arbitrary but essential to reality. Making sense, nobody told us this. We had to figure it out. We had to observe carefully, think clearly, do the mathematics, test the predictions. And we got it right. The theory of relativity makes predictions that have been tested thousands of times in thousands of different ways. Every time the universe agrees with what the theory predicts. That's extraordinary. That's the power of human curiosity and human reason. So here we are. There's a wall, an absolute wall at 186,280 miles per second. You can approach it as closely as you like, but you cannot cross it. Nothing with mass can cross it. And now you know why. Not because we need better technology, not because we need more energy, but because crossing that wall would mean having infinite mass, requiring infinite energy, experiencing zero time, and breaking causality itself. It meant the wall isn't there to limit you. The wall is there to keep reality coherent. And it ensures that cause always precedes effect, that time flows forward, that logic works, that the universe makes sense, claims every photon that reaches your eye, every gravitational wave rippling through space, every signal carrying information, they all respect this limit. They all move at or below the speed of causality. And that's not a bug. That's a feature. That's how reality works. The universe has a speed limit because the universe has structure. Beautiful, elegant, mathematical structure. And the fact that a pattern of atoms that happen to become conscious can understand this structure, can grasp why the limit exists, can see the profound logic behind it. That's magnificent. The universe doesn't owe us understanding. It doesn't owe us elegant laws. It doesn't owe us anything, but it turns out the universe is comprehensible. Its deepest secrets can be uncovered through careful observation and clear thinking. The speed of light isn't really a limit. It's an invitation to understand how reality truly works, how space and time are connected, how causality operates, how the cosmos holds together that wall you can never cross. It's not keeping you out. It's showing you how the universe is built, and that might be the most wonderful discovery of all. Thank you